Let's go. Starting. Oh, let's grab these. Cool. It looks like we're live. Yeah, we're live. Everyone, FusionEd coming at you, and welcome back to our weekly FusionEd Livestream. Apologies again for not being able to make it last week, but the graduation was awesome, and it seems like a lot of people enjoyed Valve's lab render video, so that's super excited. I'm glad a lot of people found that interesting, so that's really cool. And so yeah, today I'm going to be working on the slingshot. You can see a little preview right here of kind of the scene that we built up to just kind of show that off. And before we get started, I actually wanted to put up a poll in the cards of this video, and there should be a little eye icon on the top right of the video. So if you could fill that out, that would really help me. I mean, particularly, I just kind of want to find out what's useful for you guys, whether it's these live streams or videos or a mix of both, and just let me know, and it'll help me just figure out what makes the most sense to do moving forward. And the reason I'm asking is just primarily because a lot of people seem to like the lab render video. But yeah, so just kind of starting out here, let me jump into VR. And so, I mean, this is Unity's robot lab scene that we took, and then we built this custom rig for the slingshot. And so I can just throw my controller in. Oops, come on. And of course, as soon as I start the stream, it's not working. That's just, I guess that is, hold on, let me, where's that game view? Game view, let's try that one more time. The beauty of going live, right? All right, one more time. There we go. I'm not sure what happened before, but as you can see here, we have a nice little projectile view of where this thing is going to go, and it's animated, just kind of move forward, and that just kind of lets me know where exactly this thing is going to point. I can pull it back, pull it forward, move it left, right, all of that good stuff. I can even throw it to go back behind me. I don't know if you guys can see that. But and then all of these, just like in the Valve's Slingshot game, we have a bunch of explosion boxes. So if I actually go and hit we get a nice explosion effect. And I think that's really cool. Interesting. I think the explosion that might be why. Well, clearly there's a bug that I didn't actually check out beforehand, but as you can see, it does explode, and we will fix that bug in the actual implementation of this. Let me go ahead and set that down. The things you do when you're debugging minutes before the stream, right? So let me go ahead and close that. And then put that there. And I guess as far as the art assets are concerned, my partner Abdo is in the chat as always. Let me actually open this up. And so if you have questions about 3D modeling or anything along those lines, feel free to hit him up. And if you just have questions about your own projects or anything in general, make sure to put those in the chat as well, because I think the beauty of these streams is also it's like an interactive time where I'm here helping out, but like a bunch of others in the community are also helping out. So hopefully you guys can get a nice chat going on as far as other stuff you guys want to work on. And I think that's really cool too. So yeah, so that's the scene. And I'm going to go ahead and start a new project. Let's go to new project. Let's call this Slingshot Livestream. Make sure 3D is selected, and then cross my fingers because sometimes it doesn't open up in 3D. And any day now. There we go. Cool. And I guess before I mention that, if you want to get the starter projects, I put this in the chat before. You can go to fusevr.com, and specifically, let me just go to the vr.com website. If you hit continue reading, there is a download link for this specific project right here. So you can download the assets that we're going to be using as far as like following along with the stream. So that's cool. Is this okay for new people? I've been messing around with it lately. Yeah, I actually, definitely if you've been messing around with it, I think this is a great opportunity as far as like learning how to build a pretty simple project. And like, I will try to keep the code as minimalistic as possible and just kind of walk through it a bit slowly. Like, let me know if I'm going too fast with anything and I can slow it down or speed it up. So yeah, that's the story with that. So starting off here, I'm going to go to the asset store and get the Steam VR plugin. As I mentioned in the previous or in the lab render video, like you have native support in the beta, but since it's still a beta, there are some issues with it as far as like just certain features aren't working accordingly. So plus also like you don't get the controller support. So I still like going to the Steam VR plugin and getting that from the asset store. And yep, so I mean, if this is your first time, that'll be a download link. I've actually already gotten the Steam VR plugin before, so it's an important link for me. And I'm gonna go ahead and hit import. And that just takes a few seconds there, because FusionEd won't be skipping. I will not be skipping any step. You will have everything. And we're just going to, you can look through all these settings here, but I'm just gonna accept them all. And we get this silly dialogue where it's like, you made the right choice. And of course I made the right choice. And then the next thing I'm going to do is actually go to my desktop, and I have already downloaded all of the assets, or I mean, I've already had all the assets on my desktop. So I'm just going to go ahead and drag the Slingshot and Boxes plugin or model into our assets folder. And I'm actually going to go ahead and I'm going to go ahead and create a folder, call it models, and then drag that in. Oh, interesting. Wow, okay, that is really weird. Like literally right before the stream, this object here, the slingshot was textured, and now of course when I pull it in during the stream, it's not textured, which is interesting. Weird. We'll fix all of that stuff later, but I just kind of find that strange because literally 30 minutes ago that was working. But that's okay. And I'm gonna go ahead and add in a 3D object, and yeah, Abdo can testify to that. It was working, like he saw it work, and then of course it stops working. I'm gonna make this size of this plane a 10 by 10 by 10, just so it's a lot bigger, so we have nice scale for that. And I'm also going to put the slingshot in at, let's go ahead and reset this and move this to, oh whoops, to 0, 0, 0, and then I'm gonna add in the Steam VR plugin. Just drag and drop that in. As you can see, it's right there. And I'm going to, whoops, not move that. I'm going to move our slingshot and boxes model. And I'm gonna put that like right in front of our Steam VR workspace. And I'm actually just gonna go for now and delete the crates. So get rid of those because we don't need to look at them right now. And I'm going to shrink this down just a little bit to like 0.5, just so that we have a good scale to play around with when we're in this play space, and it's like it matches about the same height as us, which I think scale is really important in VR, so it's good to get the scale pretty much right, and that's just something to play around with. I just cut it in half so that it matches kind of the play space area. Yeah, it did work earlier. I don't know. I don't know what happened. Well, we'll figure that out later. But so now that we have it in here, let's actually hit play. And so just so that you can see, it's working within Steam VR. I'm gonna grab my hands. You should be able to see them. And yeah, it's about the same height as me, which is good. We have my controllers working. And so all of that we get by default. It's a good time. And I would just want to show you the rigging that basically makes this model work. Is so if I pull if we open up Slingshot and boxes, go to armature, parent bone, and then band bone, if we basically pull this back, we get this nice effect where it actually moves up and down and left and right, and it's all rigged properly. So this is the part about 3D modeling that Abdo can best answer, is like how you would actually go about doing this. And I know he spent a lot of time working on it, so if you have questions, I'm sure he'd love to hear them. And so that's basically what we get with our model, which is super neat, and it just really adds a lot to the visuals of it, just being able to see that the stretchiness of the bands. So that's really cool. And then the next thing we're going to want to do is let's go ahead and really simply just create a reload mechanism. So basically, whenever there's no ball attached to the slingshot, let's go ahead and add a ball to the slingshot. And that ball is just basically going to be what we're going to be tossing around. Actually, I'm going to first remove that. You don't need to do that, but I do it mainly for sanity. And for the ball, we're just really going to use a simple sphere. And I'm going to reset that to the origin. And so it's a little big. I'm going to actually, well, let's see. I'm going to parent it to the band bone. And so that basically means that as I move this band bone, where is it? Yeah, that the sphere moves with it. And I'm actually just going to reset the sphere to, not that, reset the sphere. Wait, what in the world? Where did the sphere? Oh, okay. The sphere got huge. I'm gonna reset the sphere to be like a lot tinier. Like that's still ginormous. 0.05, 0.05, 0.05. That is still ginormous. Maybe like 0.01, 0.01, 0.01. Ah, that looks reasonable. So yeah, so like it's not perfect, but it just kind of just making sure again that scale is right. Maybe even a little smaller, like I don't know, 0.08 is probably a good number. Yeah, just so it kind of like fits within the slingshot area. And so now we have a sphere, and I'm just gonna call that ball as opposed to sphere. And I'm gonna go ahead and drag that into my assets folder. And that basically is just gonna create a prefab. And so now we will be able to spawn that a lot more. And so now that we have the prefab set up, we can go ahead and create our first script. So let's go ahead and do that. So create C#, and we're going to call this, let's call it Slingshot. I called it catapult in my test scene, but we can call it whatever we want. It doesn't really matter. And for those who've actually seen my previous versions of these streams before, you know I use MonoDevelop. I actually had to switch to Visual Studios for this stream because one of the assets we're going to be using is a JavaScript script, and for whatever reason MonoDevelop was having a really strange time, so I ended up switching to Visual Studios. And like the feel is the same, but yeah, and this works with having multiple scripts in your project, whereas MonoDevelop didn't. So that was interesting. I guess that's just a bug with MonoDevelop, I'm not really sure, but still something to point out, I guess. And so I'm just going to create a ball prefab. So that's a public variable that we'll be attaching the ball onto. And next thing we're going to do is go ahead and get a reference to the sling, I guess is what we're going to call it. So sling game object, and just call it go, which is like an interesting acronym for that. And so we're just going to have both references there. And I'm going to create a private variable, that's a Boolean, and call it ready. And ready is true. And basically, this is just going to be our variable that tells us whether or not our slingshot is loaded. And so, yes, I don't need to do anything at start at the moment. And so what I'm going to do here is if ready. So update is called every frame, and Let's see. Yeah, there we go. I cannot type for the life of me today. And so if ready, what we're going to do is create our ball. And we'll call it ball prefab. And we're just going to get a reference to it. I'm actually also going to create another private variable. I'm going to call that current ball, just so that we have a reference to the ball that we just created. And whenever we're ready, we'll have that reference. And I'm going to say curballs.transform.parent equals slinggo.transform. And basically what that's saying is, if you remember in Unity here, we had it parented here as the band bone. We're just basically doing that in code. And so then the next thing we're going to do is curl.transform.local position equals vector 3.0. And that basically is just going to reset us to 0, 0, 0 locally, which is basically the exact same position as wherever that band point was for the sling. And so if we actually go ahead and run this, and I'm going to, well, before we run it, we have to set it up. So I'm going to add the slingshot, going to add our ball prefab in the correct spot, and we're going to add our band bone to the sling go. And I hit Control S, and so I'm just going to create a scenes folder. And we're going to go ahead and call this slingshot test scene. Does anyone know the average time this should take to make? Well, this, I'm going to try and make it in 2 hours, which I think is doable. But as far as prepping it, like I ran into some issues. So like, if you're starting like from scratch, like you might sometimes run into like unexpected issues, but like that's just the part of debugging. And I try to like simplify that out as much as I can. Although I've clearly run into bugs along the way too, and that's just part of the development process. And so let's just go ahead and run this. And as you can see, that ball is super tiny, and it's also spawning a ton of balls because so there are a couple things. So one is I didn't get the scale right here, so I'm just going to set that back to 1, 1, 1. And then the second thing is I forgot to set ready to false because we only want to create one ball. And so now if we go ahead and do that, still a little big. So like we might on the prefab like make this, I don't know, 0.5, 0.5, 0.5. But like it's definitely not as big as, yeah, maybe a little smaller, like 0.4. Like I said, scale is just something you play around with. Yeah, that looks about right. And it's pretty centered as far, it doesn't look centered here, but like as far as like where that game object is, I think that's like centered onto it. So yeah, and as you can see, like the position 0, 0, 0. So all of that is set up right, and the rotation's right. Perfect. Perfect, perfect, perfect. The Inaudible Gamer. That's a cool name. And welcome to the stream. And actually, I can move this a little closer, just so I can actually see. And so yeah, so now we're spawning a ball, and that's super simple. Now the next step will probably be, let's go ahead and take this controller and reach out, grab it, and then pull it back. And basically, it's literally just making sure what the steps we have to do are check that our controller moves into the space that we want to collide with, which is that slingshot area. And once we do that, we want to make sure that we know which controller touched us, and then just move it back to wherever the position of the controller is. That's what we're going to implement next. And actually, we're going to start in Unity first because we need to set up a few parameters. So the first thing we have to do is add a blocks collider. And I'm actually going to, for this, disable the plane so that I can actually see where the box collider is. And as you can see, I think it's like really tiny right now, or like really huge. Yeah, it's ginormous. So We'll just go ahead and like make this 0.5, 0.5, 0.5, 0.1, 0.1. Just get it manageable. Maybe like 0.01, 0.01, 0.01. That looks about right. We might make it a little bigger. For this, I'm gonna go to Edit Collider, and we can just resize it manually here, which is, I think, super convenient. And I'm just gonna disable that, and then move it back in the Z direction, like negative 0.01. No, not the Z direction, in the X direction. No, in the Y direction. Orientations on this thing are like all messed up right now. Even further, yeah, okay. That looks a bit more reasonable, and I think matches well with the slingshot. This is interesting. Like when we imported this in previously, like all the scales were reasonable. I don't know what's happening with the scales right now. I think it might have been something that I did with the setup. Whatever, that's fine. I think once we import in the robot lab, some of these things might be fixed because that thing has its own project settings associated with it, which might help. But for now, let's not even worry about it. Let's just get the scales the way Unity wants them. And so that's that. So we added a collider here. I'm going to make sure it's a trigger, which we will talk about in a bit. And then the other thing I want to do is, I think the controller should be active now. Oh wait, it turned off. There we go. Yeah, you can see the controller in Unity. And I'm going to go ahead and add a box collider onto this guy. And again, that's also big. This one was expected, so I'm like 0.5, 0.5, 0.5. Make that small. Let's go ahead and edit the collider again. Get it to what exactly we want, just so it fits well. Oops. On the here. Let's get it approximately right. And then the reason we're using, well, one for these controllers, since we don't actually have access to the mesh at editor time, we won't really be able to add a mesh collider to them. And they also, like, the controllers are built out of a bunch of different parts, which makes it a little hard to add a mesh controller onto it, because a mesh controller usually, oops, there it's drifting. A mesh controller will usually basically, if you have the whole mesh model, then it'll wrap around the whole mesh as opposed to like individual parts. So that's one of the reasons we're using box collider. Box collider is also just more efficient. And I'm gonna go ahead, since we did that at playtime, we need to apply these at runtime, or in the editor, sorry. And just because in playtime nothing gets saved, so we need to make sure we copy whatever we need to beforehand and then apply them afterwards. And Billy, there's no stupid question, so like ask away. That's the point of these streams, so that we can actually like all talk about it. And how'd you get the blue outline on the play area? I thought it was actually there by default. It's a checkbox on the component. Oh, okay. Yeah. It's this, yeah. So yeah, it's this play area script. As far as in the editor, I thought it was there by default. I think you can change the thickness. And maybe that might have been a setting I changed and I didn't even realize it. But that, yeah, that's, I guess, how you get the blue. Like it's playing around with this thing. Yeah. So let me know if that helps, or if someone else is able to figure that out. But yeah, it's I think set by the play area. So with that there, we have all our colliders set up. I'm gonna go ahead and put the plane back in, just so we have a ground to stand on. And we're just going to switch back into Visual Studios, and this time we basically just wanna, oh, actually the other thing I should mention, no, I'll add this here. So to basically check to make sure that we are entering basically that area of that slingshot, we're going to write a method called void on trigger enter, and then we're going to pass in collider, other is the parameter. And so this gets triggered basically whenever you have a collider that we just added to the controllers that enters another collider. And the one thing you actually have to do for that method to work is you need to go to wherever that script is and make sure there's a rigidbody associated with it. And I'm just going to remove gravity and get rid of the is kinematic, or like add is kinematic. That basically says like don't apply the physics calculations to this object. It's just kind of there for stuff like the on trigger enter. And that's actually why we had to make sure that this is trigger was on in the first place, so that this event gets called in our script. So that's just kind of the basic setup for getting that. And just to kind of test this and make sure I'm not going crazy, I'm going to add a log statement here and just say got here. And another thing, since we started from a new scene, all new scenes have by default the main camera. And yeah, that main camera, we don't need that for VR because we have our VR camera. Okay, so I think is that right? So about here, let's hopefully I should be getting called. Yep, I got here. So yeah, so we have got here's, and basically knows. So now we know that this guy is now going in there. And actually, what I'm gonna do now is I'm gonna go ahead and rotate the camera rig just so it's a bit more convenient for me. You don't have to do this. It's more just so that everything here is aligned in front of my my webcam, so I don't. So like now, if I like instead of it being off to the right, it should be like literally right here. Yeah, like that should be good. I can be lazy and test from my chair. That's basically what I wanted to do. So now that we have that, let's go ahead and one thing I need to do is because I always forget the syntax for this thing, is I believe it is in, where's that test throw? Yeah, test throw. In test throw, that we're going to be using this code, so I just want to have that open. It's basically for checking whether this trigger is pulled. So what I'm doing is I'm going to check that my controller enters the area, and if I pull the trigger while I'm in there, then I'll be able to pull back. So as opposed to just like going in and then automatically attaching, which feels a little weird, you can just go ahead and choose to pull the slingshot back and then pull it back. So I'm gonna do that, and so to do that, what we're actually gonna do is create yet another variable, or actually two. One called Steam VR tracked object, tracked controller, and then we're going to create another one called Steam VR, or sorry, not Steam VR, private pool. We'll call this in Slingshot, and this is set to false. So what we're going to do is, just for sanity checking, what we're going to do is call get other dot get component Steam VR tracked object. And so this is, if we go to the left controller, that is this component here, the Steam VR tracked object, and it's attached to both of our controllers as well as they have. So basically, we're going to check and make sure that our tracked controller is there. Tracked controller, and I guess this is, I'm sure probably all of you guys know this, but like this also should work with Oculus Touch, which I just think is so cool. The fact that we now like Steam is like supporting like both of those controllers, and like very few people seem to have Oculus Touch controllers, which I think is interesting, but still something to note. If you have Oculus Touch controllers, you can follow along, and I think that's, I guess, Oculus Touch or Hydras. And so if the track controller is not equal to null, we're actually going to go ahead and set in slingshot equals true. And so yeah, so that about does it for that. So now we have a reference to which controller touched the slingshot, and we know that the whole script knows that the controller is currently in the slingshot. And what I'm going to actually do is do the exact opposite. And this is in the case that on trigger exit, and it's literally the exact same thing, except instead of telling us that we entered the slingshot, it's telling us that we pulled out. And we know which controller did that. So that's cool. And so now that we have enter and exit, we can now go ahead and go to our update method, and we can say if in slingshot, then what we're going to want to do is, oh, here's something I forgot. So I'm going to first actually, so this is how we explain this. So when I move this point here, actually I'm going to hit play so that everything resets. So when I move this bone on the rig, what'll end up happening is, so it moves it and everything stretches accordingly. But the problem is I've lost the point at which this thing should start from, and I just hit Control Z to actually get back to that point. So I want to make sure I remember what that exact start point is, and so I just need another variable that I'm going to call here, and this is just going to be a vector 3, which is just the position of slingshot start. So just gotta save that data, and we're gonna do that in start, because as soon as we start the game, we want to be able to have that variable. So slingshot start equals sling go dot transform dot position. So you're just gonna save that in the start. And so now that once we've saved that, we'll come back to that in a little bit, but I just wanted to mention that now, because otherwise I know I'm going to forget and be like, why is it not working? So now that we have it saved, we can actually go ahead and say sling go dot transform dot position equals tracked controller dot transform dot position. So we haven't added the tracking just yet, but what I believe I just did is, so now if I move it there, now I mean I haven't pressed the trigger, but like as you can see, it's now following my controller, and it's of course updating accordingly, and like all of that's cool. So now let's just do it. Let's just quickly add in, if I pull in the trigger, then it'll touch. And that's actually really easy to do, and I already pulled up the test throw code. I'm just going to go ahead and copy that. And again, that's in SteamVR Extras, SteamVR test throw. I always copy it because I can never remember what the exact syntax is for it. And I feel that this is just like one of those things like where it's not documented well. So, oops, and just copy. Instead of tracked object, we'll call it tracked controller. We get its index, we get a device. I'm actually going to move this outside of this if. And I'm actually also going to check and make sure that our tracked controller does not equal null. Just because the first time we go through and we haven't actually collided with anything, the tracked controller will be null. So this is just kind of a check to make sure that doesn't happen. It's not a super big thing, but like fewer errors in the console. And so yeah, we have a track controller index. If it's in Slingshot, if we get the touchdown event, then we are basically, actually, sorry, let's call this get touch. If we get a touch event, which is basically when as soon as we pull it down, then we know that we should update our position. So controller here again. If I move it here and it updates. If I actually let go of the controller now, it should I can let go. So and then it just kind of holds in place. So that's again pretty simple. How many lines? This is why I like mono develop. I'm sure there's a setting for this. I don't know how many lines I've written so far, but not that much lines of code to get the slingshot basically working, as far as like movement is concerned. So the next step is, so now we say we're pulling it back, and then I guess as soon as we let go, we basically want to say that we want to release, and so then it just kind of resets back to the original position. So if it's in Slingshot, then what we're going to want to do is specifically, I think we want to do this first. I'm gonna write code and then test because I can't remember. So actually, let me just copy this and then make this work. So get touch up. So that's whenever we get touch up, which is like we release the controller. I'll make this an else if. Then we basically want to have it reset. So what we're gonna do is in slingshot equals false. So basically we're done being attached to the slingshot. And I'm going to move this one line up just for formatting purposes. And so in slingshot equals false. And now what we're going to do is sling_go.transform.position equals start slingshot start. So then basically as soon as we let go, it should just resets back. Come on, there we go. So there we go. So now we have all of the actions going, and so next step after that is basically making sure that we send the ball flying. And for that, what we're going to want to do is we're going to go to our ball prefab, and we're going to make it a trigger, just so that we don't get some awkward interactions where the controller accidentally hits the ball. So basically, a trigger will avoid it from actually doing any collision detections and like moving things around, especially once you add a rigidbody in. So like once you have the rigidbody, like it'll basically try to make sure that no colliders are overlapping, which we don't want in this case. We basically just kind of want our hand to pass through the ball when we're pulling it. So for that, we specifically just going to make it a trigger for now, and then we'll update that later. But so we have the sphere, we have a mesh render, and then I added a rigidbody here. I'm going to turn off gravity, and we will play around with the actual settings to like make the physics look good a little later. But for now, we're just going to leave the basic mass. I'm in the probably in like 10 minutes or so, I'm just gonna increase these masses just so that we get a nice feel as far as like velocity and mass is concerned, and just like when we actually make impact, it's actually making a big, powerful impact as opposed to it's kind of like bouncing off, because that's not something we want. And so what we're gonna do is on touch up, we're actually gonna go ahead and get the current ball. And we're going to say get component rigidbody. And yeah, again, let me know if I'm going like too fast or too slow, and then I can adjust accordingly. And I'm just gonna actually save that in a local variable, rigidbody r equals Kerbal get component rigid body, and so that's the rigid body. And then what I'm gonna do, or sorry, first what I'm gonna do is actually up here kerbal dot transform dot parent. So we're gonna unparent it from the slingshot so that it's like kind of its own free object. And then we're gonna reset that position and, or yeah, unparent it and then set the position. And then, so now it's its own object and we can set its velocity. And for now, I'm just going to say vector3.forward just to make sure everything is working. So this is at 100 meters per second, I believe, is what the units translate to. And let's just quickly test. And we sent it flying. Really far, actually. And as you can see, like, so what we need to do here, if we want to get another ball, is actually go ahead and set ready back to true. So in doing so, we should get another ball, and then we can continue this loop of just kind of attaching balls. Yep, 100 is really fast. And as you can see, vector forward is in like some random direction, but that was just primarily for testing. I can actually, let me actually go ahead and drop this down to 5 so we can actually see what that direction is. Yep, so that's forward in global space. So it's just kind of going off where it pleases right now. And it starts from wherever we held it, right? So like if I held it closer up here, it'll start from there. And if I pull it all the way back here, it'll start from there. But so now what we just have to do is make sure we get the direction right. And for that, what I'm gonna do is the velocity. So basically, it's gonna be moving from where the current ball is to wherever that start position is. That's basically the direction that we want to throw in. And so basically that direction is, instead of vector3.forward, it is kerbal.transform.position, and I'm doing this in the wrong. And then it's slingshot start. Oh, I actually spelled that right. So slingshot start minus kerbal position. So that is the actual direction we want to throw in. So now let's try that out. And again, this is just slowed down so that we can actually see what's going on. We can obviously make that a lot faster. And so there we go. It's going in the direction that we want it to. We can also, this will be really dramatic, but what we can do is say not use cone friction. Actually, I don't even know what that does. And set that to true. And so now when we actually do it, it should just kind of go plummeting down really fast. Yep, there you go. Actually, I think I actually do want it to start from where it was initially. So for that, I'm actually going to switch this around. So I'm gonna reset that location, and then I'm going to get a reference before I do that to ball pause equals this dot position. So I'm just going to get a reference to the ball's position before I throw it, and then I'm going to reset it there. So it gets so because I keep it parented on, so basically the ball will stay parented to the bone, and then I reset it, and then I remove that parenting, so the ball will move with it to that position. And as opposed to like starting from where I pull it from, it's actually going to start from that start position. So they're all going to start in the same position, but they're going in the right direction now. And that just kind of feels or looks a bit more natural. Although natural, you can obviously do whatever you want, but just know that oops, there we go. Just know that the order is important. But yeah, so we have a basic slingshot. and it's reloading. Yeah, everything's kind of working. And there are a couple issues that I will point out, and I don't. If we have time at the end, I'll fix them. But one thing you'll know is this kind of depends on the size of your play space. But if, for example, I pull back here, or actually no, I pull back about here and then let go. So now the trigger won't work because we have to actually leave and then enter in order for the booleans to actually be set right. Because otherwise what happens is this onTrigger event is never called because we're still actually within the event. So, I mean, you can fix that by adding in another boolean to, or if you use the onTriggerStay method, that will introduce some issues. And you basically have to do a bit more error checking, but just to make sure like it feels right and like, oh, I'm actually still within it, and then you do that checking. But otherwise, this works for the most part. And so, see how we're doing that time, 10:45. That works. So we now have this slingshot. We can, let's go ahead and okay, let's go ahead and like work on the physics, I guess. So for that, what I'm gonna want to do is we're gonna set the mass to, oh, you know what I'm gonna do first, because this is actually not terribly difficult. What we're gonna do is actually add that projectile viewing script, and that's actually not terribly bad. And so let me actually open this up. So if you Google around, actually let me post a link to this in the chat so you guys can see it. But if you Google around for, there aren't too many parabolic style lasers or like line renderers out there, and I've spent a little bit of time Googling around as opposed to implementing it myself, because if you can find it on Google, might as well use it, right? And so if you find this specific thread, who was it? Seth here, he was kind enough to actually like provide his own implementation of a projectile line render, as you like see in these pictures, and that's just useful for in VR specifically, like being able to see where your objects are going to go. So that was implemented, and I think that's just really cool to actually see where it's going. I believe also in Stone Fox's his plugin, I believe he also implements something to that effect. I haven't actually played around with it, but I believe there's also something there for the actual laser implementation. So this is, I think, super cool, and kudos to Seth for actually like making this available for people to play around with. This is written in JavaScript, which is actually, again, this is what I mentioned before. This is why I actually switched to Visual Studios instead, is because you'll need Visual Studios in order for the editor to actually recognize what's going on. And for that, this is also provided. I believe I put that within the starter project on the website. But we're just going to go ahead and drag laser arc and projectile arc into Unity. I'm just going to drag them in here. But in order for Unity to actually allow C# and JavaScript code to run simultaneously, we actually need to make sure the JavaScript code is compiled first, because C# is using it. And to do that, we just have to make sure the JavaScript stays within the plugins folder, because the way Unity works is it'll compile everything within the plugins folder first, and then it'll compile things outside the plugins folder. So putting that here just kind of guarantees that this is the first stuff that Unity recognizes, and you'll have the namespaces and everything correct. So just keep that in mind. Otherwise, you'll run into errors and you'll be like, what is going on? So that's that. And so now what we can do is actually go ahead and on our ball prefab, I'm going to go ahead and add a laser arc component to it. And that, so now if we actually run that, I believe, so yeah. So that the laser arc isn't set up properly because in order to use his script, what you need to do is provide, he calls it cube, but basically that is going to be what the starting point of wherever you want your wherever you want the the line to start from, and then you provide also the projectile, which is the rigid body, and that basically gives the settings as far as like mass is concerned, so that the script is basically able to calculate what exactly that projectile will be and then calculate points along the way. So we just have to set those. Actually, we can set them because our cube here, or the ball, is going to be the start point and is also the projectile. We can set them right here. We don't even have to set them in code. The only thing we need to set is the velocity. And so we can do that. We just need to, within our catapult, if we go back to, yes, reload. Yes, reload the project just so that it knows that the JavaScript was compiled. And here, actually, what we're going to do is we can set the velocity. So the velocity right now is set to 5f, but and it's also, oh no, yeah, it is based actually on like how far we pull back. So all of those settings are correct, and I'm actually quickly going to just create a float strength and call this 20f for now. Strength is just going to be like how much force we want, or not force, but like how much speed we want to apply to our slingshot. And I'm just putting 20f there for now. You can play around with that to see what makes sense for you. But that's just going to be the velocity that we want. And the other thing that we basically want to do is, so we've set the cube. Actually, wait. Let's actually go ahead and run this. And yeah. So it's not pointed in the right direction, and that's just because, wait, it should be pointed in the right direction unless this is. So if I rotate this, yeah, there we go. So yeah, it is, what is, so we can fix that. It's just adding a look at to our ball. But basically what we want here is curveball dot look at our transform. It's basically just not looking in the direction we want it to look, so we just have to make sure it does, which is it should just be looking at the start position. So now I'm just going to pull this out in the blue so that it happens all the time. And oh wait, okay. We also need to fix this, which is just adding material. And oops. Okay, yeah, that's just a look at is not in the right place. We can let's pull this back. Yeah, there we go. Yeah, there we go. So yeah, it's behaving right now. It was just kind of the initial settings were off because when you first started off, the slingshot start and the ball are in the same spot, so like it doesn't really know where to look at. But like afterwards, it's fine. And yeah, as you can see, there's this nice curve and all of that good stuff, and that's just primarily set by like whatever the velocity is that we provided. Like, but all of these, the projectile projections are all calculated like based on the mass and based on the velocity we're setting. So that's all fine and dandy. Actually, mass. Well, now that I think about it, mass doesn't apply at all because it's just gravity working on it, which is just applying just a vertical force. So, or a vertical acceleration. So that's that. And we also, well, I'll add in the rest later. Actually, how are we doing on time? So 11. Let me fix the material for the ball, and you can do that really easily by creating a material. We're going to make it or let's first name it. Let's name it projectile mat. And I'm going to pull in yet again. I added a small PNG file. That's basically just going to be those markers that we saw in the beginning. of where basically showing off where exactly it's going, and then having that animated. We just gotta make sure alpha is transparency is set up so that the actual thing is transparent. And I'm gonna go ahead and add that to the, actually no, I'm going to create it an unlit texture, and yeah, the texture is already set there. You would, otherwise you can just drag and drop the beam texture onto the texture grid. And on the laser arc, I'm going to go ahead and add a material and just drag that in. So now, yeah, so that's animated. If I pull this back, yeah, there we go. So just like that, it kind of works, which I think is really neat. And you get this nice projectile, and it's all animated, so we'll know exactly where it's going. So that's super cool. And why is this in the way? Okay, sweet. I can pull this out of the way. And there we go. That's pretty much that. And it's about 11. So I think the next steps are really just making sure we set the variables in the laser arc accordingly. And then we actually just add some boxes and add some explosives and like get the scene looking nice. Before I take a break, just so that people can catch up and chill or relax or whatever, I'm going to just get this running in the background, which might impact performance, but whatever. And it's just downloading Unity's Robot Lab in. So I'm just gonna go ahead and grab it. And it's a 4x project, so it's kind of old, but I think it still looks really cool. So I'm just gonna go ahead and import again. How big is this? I think it's like half a gig. Yeah, it's like 576 megabytes. So it's kind of big. So if you don't have it, you can go ahead and download it. It'll take a little bit of time. Even decompressing the project is taking a while. So it's a bit of a project, but just the one thing I will point out is make sure you uncheck project settings. And the reason for that is I'm still not entirely sure why this is happening, but for whatever reason, when I import that, SteamVR suddenly starts crashing. So I feel like some setting that is archaic to Unity 4 that doesn't work in Unity 5, and it's just causing Steam to crash. So if you use this and are using it with SteamVR, just make sure you uncheck project settings. But with that, I'm going to just take a 5-10 minute break and hop into the lab and then actually play the slingshot, see how far we get. Here we go. Yeah. And actually, I don't even remember what my high score for this game is. But Slingshot is definitely one of those very interesting games where it's like I'm still not entirely sure how to like clear everything, but I'm sure there's a way. And but like it also like lends itself to having a max score, which like for example the bow and arrow doesn't, and I don't think Zortex does either. So go ahead. Where is this? Nothing. Alright. Cool. Start. That was weird. Like this controller was off, but it was in the exact location that it was supposed to be. Grab the other controller, which is here. Yeah, that's full screen. Cool. Yeah, it's a little laggy in here because I think it's still importing that stuff and Unity is open, but that's fine. I don't do that motion sick, so it's not the end of the world. I mean, I would get motion sick if I was spending a lot of time in here, but and I messed up in setting the room scale because like now it's like situated backwards. So or this is sideways, right? Yeah, it's like situated kind of sideways, so it's not the most ideal for actually like showing you guys what's going on. But oh well. There we go. I think. Interesting that that hit. Oh, okay, the tracking is still there. Wow, this is taking a surprisingly long time. But yeah, now it's actually like pretty smooth. Actually, can I move it backwards? No. Oh well. Rotation's not right, but that's fine. But yeah, they actually like highlight your controller when you get it, which I think is convenient.
So excited. Are you the calibration guy?
Let's see.
Great, great. It's my first
And like Slingshot's like one of those interesting games where it's like, oops. It's like, this could easily be played on a 2D screen, but at the same time, like, there are like some neat effects for like using your hand controllers. And
that I may cause climate change and raise awareness of the changes I am making to the
tracer
planet.
core. But like also like the fact of like actually like, moving this into your head so that you get like a better sense of like where this is going to go. Like I think that's an really interesting effect that you wouldn't be able to get on a 2D screen.
Filled with putrid water, dead rats, and old garbage.
Go.
Oh,
I'm doing pretty bad. No, I lost the tracer core.
Please note, I will not dispense fruit punch until I am calibrated.
Nice. And yeah, that definitely makes it a lot easier to see what's going on. And then, yeah. This is actually, oh, it's interesting. Yeah, it's interesting to see that they're also using a line render. And like the way I can tell is actually by, if you look at it, okay, let me pull this back. If you look at it and then just kind of move your head, it's always rotating to like face exactly where you're looking. So it's always facing it towards you. And I think that's just a really neat effect. So I'm gonna go ahead, so here, so I'm gonna be hitting that tracer core, but I actually want to know where exactly, so it's like about this direction to get the other tracer core. There we go. So it's like about here.
Welcome to a world of wonder.
Like
Do you like magic? No?
Here.
Well, if you don't like magic,
All
what's
right.
that behind your ear? Go ahead and look.
That was way off. Actually hit something.
I am a useful core. I am not a gateway to the netherworld.
I suck with this. I didn't really do a lot better, but I can at least say that I'm getting all the tracer cores, because that's pretty easy to do. That's like part of this. That's part of this game. It's like once you have the tracer cores, you can get all the tracer cores. You just need to get one, and that'll help with the damage. I also really love all of the little comments that are in this game. Uh-oh. Uh-oh. Wait, there were no explosions? Well, that was convenient. Let's see, all the way up there. Yeah. And also, like, the physics is pretty accurate in this game, which I think is really cool. I mean, it's just, I believe this was written in Unity. And someone correct me if I'm wrong. I think, yeah, they announced that this was written in Unity and it's the only project in Unity. Let's go to that one. And, like, the only one that wasn't written in Unity, I think, is... Oh, come on. Give it to me.
Calibrating things your way and it didn't get us.
There we go. Oh, come on, really?
No more
Yeah, give me the rest. Give me the rest.
It's impersonal.
Ah, that's
My
wrong.
methods may be orthodox, but I get results.
Oh, I did get it.
Carefully, I'll see you in heaven.
Oh, that was sad. Sad times are sad.
I am the snuggle core. Do not snuggle me, or I will explode.
Wait, where did I shoot from? I shot from up here. I needed
I
about.
was designed for the most pleasurable
Is that
snuggling
right?
by humans. If you snuggle me, I will snuggle me.
No, I missed. Oh well. Oh well, that's game over.
Well done. You have calibrated cores and safeguarded.
Oh, I'm not connected to the internet. That's why it's,
property in
I
your
don't
cube.
see the
You will be
global
given
leaderboards.
promotion at your next employee.
But yeah, no, that's a lousy score. 20,000. That's like nothing. But I think you can wait. I was like, wait, why is there another tracer core that showed up? It's like, what in the world? I'm gonna go ahead and set this down. And do that. Wait, by the way, does anyone know like how to actually set up the rotation? Like, make sure it's actually rotated to the right place? Because I think that's just like an issue I like run into sometimes. So like I'll set up room scale, and then all of a sudden it would just like it'll like be flipped, and not like in that example where I'm like facing behind you as opposed to like facing in front. So like if anyone knows how to fix that, let me know. And also I'll just make another plugin here before we actually get started. Is just make sure to fill out the polls that are in part of this video, like their annotations in the top right, or not annotations, cards. I don't know why YouTube decided to create cards as opposed to annotations and like have them distinguished, but whatever. The point is, pull in the cards. Just 2 questions, takes literally 5 seconds. So, and it'll help me out a lot. So, definitely fill those out. But yeah, cool. That's just a little break. Yeah, it was about 5 minutes. 5 minutes or so, and cool. So I didn't make a backup, but I'm gonna go ahead anyways because I believe this should work. And if it doesn't, well, I still have the test project. So I'm just gonna go ahead and close the assets. And yeah, everything should be up to date. And yeah, so we have our projectile. We're just gonna update its velocity to be appropriate. I'm gonna make the mass here 100, just so that like the velocity and mass just create a much stronger force together. And so now we have a mass, and we can, let's just update the velocity on our laser arc. And to do that, what we're gonna do is go to the slingshot stream, and we're just gonna have to reload everything. Just reload all, update the line endings. Yeah, cool. So to do that, it's actually pretty easy. So it's basically wherever I am updating velocity, I'm just going to go ahead and hit curveball dot. This is probably not the most efficient way to do it. I can actually, yeah, okay, fine. I'll do it the good way. I'll do it the good way. I won't do it the lazy way. So what I'm going to do is create a laser arc, call it arc. And whenever we create a ball, I'm just going to go ahead and get component laser arc. Boom, done. And all we have to do here is just say arc dot velocity, my velocity equals r dot velocity. And why are you not angry? Oh, right. Dot magnitude. So yeah, the one downside to this specific script is that it uses your forward, and this is why it like pointed in the wrong direction initially, is it uses the forward of the ball to actually indicate where it should be pointing, and then it just kind of gives you a magnitude for velocity as opposed to the velocity is like literally the direction that it's supposed to go. Is that the let me just actually, I didn't even read through the chat. Gotta look. Yeah, Andrew, like, I totally agree. The lab loading lag is just kind of annoying. You can stream on YouTube and it's better than Twitch. One day you'll be able to. Yeah, you can stream 360 in VR. It's just kind of shitty. Yes, a VR ID would be cool. Get a chance, Fiona. Could you let me see your collider scripting? Collider scripting, as in like, which collider? This collider? Just did you want to see just kind of the numbers I used? At issues, if you had both controllers in the same area, it would randomly. Oh, yes, that is actually something I didn't account for. You can obviously like add in more checks. Like I think you're talking about this. You can add in more checks, like for example, like just make sure the track controllers are the same. So we could do that if, like, for example, if I just like did this, probably would fix it. Tracked controller. Alright, sorry, not tracked, T controller. If we say like T controller, if it's, so we'll just say like if T controller is not null, and tracked controller does not equal T controller, that should fix it, just so that you don't get the exit event called when I put one in and then take it out. And I think you might also have to do it here. Also, like if, yeah, you'll probably, you should do it here. So let's just call this var T controller. And I'm just like logicking this in my mind. I could be totally wrong, and this might be something we have to debug. But and T controller. So sorry, if T controller doesn't equal null, and T controller, this I think because it doesn't equal tracked controller, then what we're gonna want to say is, I think this is wrong. This feels wrong right now. Track controller. So this is, so if I put right hand in, it should go through because track controller was null. If I take it out, it would become, oh, this would become null. So we want to do that. This is tracked controller equals null. I put this in, then so T controller is not null, and T controller does not equal track controller, then we set our track controller, and then in slingshot is true. If we take it out, then they, oh yeah, sorry, this should be an equals. If I take it out and they are the same, then it'll be set to false. If I put in the other controller, so if I put this one in, then I put the other on trigger, enter, then T controller doesn't equal null, and T controller, so then it would actually set it to the left controller, which actually we don't want. Let's see. Wait, is there a no D? What? Okay, I think I just have to logic through this, right? So what? Okay, I guess the way you would debug this. So what do we want to have happen? We want, if I put this in, and yeah, if I put this in, basically, then, and if I put it in, I want this to be the only one that actually controls it. So it should be if this is not null, or T controller equals track controller. So then that'll ignore this one entering, because the T controller would be the same, which is fine. And, or actually, I mean, we don't even need this. Oh, no, we do. Yeah, we do. It's, and that actually does have to be an. No, it can't be an and. I guess it's like this. If T controller equals track controller, yeah. That's why sometimes I like avoid like harder logic like that, just because it seems like a small problem, but like just like getting all of the nuances right is a little trickier. But I mean, if people want that, then I'm like I'm totally down to like logic through all of this. So otherwise, so that's much better than I thought I'd have to do. Was thinking I'd need a separate method tied to. Yeah, you could do that. I don't know if it's necessarily better. I'm like trying to like reuse whatever I have, which may not be the right way to do it, but T controller doesn't equal null, and T controller equals tracked controller. So this goes in. If it's the same, we'll just keep the same logic. Or if it's null, then we're gonna assign it anyways. So that should be right, and then that'll ignore the case where the left controller goes in. So that covers this case, and then in the exit case, which is probably more important, what we're gonna want to say is, so our reference is always the right controller, and now if the left one exits, if it's not null, which it shouldn't be because the left one's exiting, and track controller equals T controller. Yeah, so now it'll only check if this one exits. So this should, we can test it out actually. This should, in theory, it should work. So if these are not on, let's turn them on. I want to. There we go. So now if I pull this, and then pull this in here, like this seems to be fine. It's not causing any issues. So, oh, I should also do that. But now, yeah, same way. That doesn't cause issues. So, let me know if that's what you wanted to see, because I think that logic seems to hold through and like avoids that case where you have like two of them entering and exiting, which yeah, I can definitely see happen. Like yeah, like in general, I think like when you're writing code, like that, this is like one of those things about VR that like, and I'll actually probably put up a video on this later, and I've mentioned this in the stream. There are like a lot of small nuances that you don't think about, but like cause a huge issue. Like for example, the fact that I can walk anywhere within my space, and this is a problem in budget cuts, is that you basically, because you can walk anywhere in your space, you can walk through walls, which then introduces like a lot of hacking as far as that's concerned. And like same here, you don't think that having positionally tracked controllers might cause issues as far as overlap, but they do. So you just have to add in that extra logic, and it just adds a little bit more work. I mean, it's not like a ton of work, like people have been doing this for a long time, but like it's just like a little few design choices that you have to work through, which I think is just an interesting challenge. Like, I mean, it means more code, but like to make it feel right to the user, like that's necessary. So now that we have that, I'm going to. Oh yeah, we already did that. Sweet. We already set the arc velocity. That's perfect. So now the projectile is working. I'm actually one thing that I want to do that's just been annoying me is, so when we're starting, I actually want to curl dot get component line renderer. We're just gonna go ahead and set no, enabled equals false. You can set your camera rig to go black when you cross something you shouldn't. Yeah, I mean it wouldn't work in say budget cuts, for example, because you would still be able to teleport, I think, which is still tricky. The thing we discussed on the stream specifically was you'd be able to just load in whatever part of the levels you wanted as you needed them, which I think is probably the best solution. Turning black, I think, is actually probably also a good solution. You of course still have to like code that in as far as like I know where my boundaries are, and if I cross them, then it's bad. How they handle it in vanishing levels is bad. They teleport the player backwards towards the room center. Oh really? I need to try that out. I didn't notice that before, but that's interesting. That's interesting. I will now try that out. Thanks for the tip. Huh. Teleport. Like I feel like that could be a little weird. Oh wait. Okay, now I know what you're talking about, because they do ask you to like walk towards just they black out the room and then ask you to walk towards the center. I actually don't like that though. I'm not gonna lie. I don't like that. As far as like it breaks the immersion, like as far as like especially in a small play space, like you're like kind of forced to be in the center, which kind of sucks. Anyway, and then we're just gonna turn the line renderer on back when I call get touch. So here, they force teleport actually. Really, they force teleport? That's kind of sad. I didn't know they force teleport you, but ugh, that could feel weird. Turn it on when we here, and then we're gonna turn it off when we call get touch up. Set this to false. And so yes, now that line renderer, which is basically the cause of our projectile. So the line arc is still running, and it's setting the velocity and doing all those calculations. So like you could also turn that off, but it's not a huge performance bottleneck. And we set it, and clearly I did not. What did I do? Oh, right. I have to do this before I get rid of my curveball, which I believe. Wait. No, that should have happened. Wait, this is interesting. Wait, why didn't I disable that? That's odd. Object not set to an instance. 58. Wait, but I'm literally accessing it right here. Wait, what in the world? Let me move it up to the top and see if that helps. Wait, what is at line 60? Like when did? Oh, I know what happened. Okay, there we go. That explains it. So actually what happened is when I move curveball to transform.parent, or sorry, move its position, this is why sometimes order is important. It actually called on trigger exit because I moved it far outside the controller bounds, and then that I think set the wait, that wouldn't make sense as far as why curveball would get set to null. Wait, where is curveball getting? Oh, wait, no, this still doesn't make any sense. Why, if I set ready to true, it shouldn't call. Yeah, okay, I'm not sure what order is happening there. That's strange. Let me know in the chat if you see something missing, but like for now, I think it's fine. I also have no idea where can I set up. Can I set up line numbers? Because this is actually kind of really bugging me. I'm so used to mono develop with the line numbers and like having all those settings set for me that like now like when I want it, I'm like I really want it. Oh wait, it might be here. Fonts and colors? No. Startup, quick launch. Project and solution. Source control? Question mark? No, text editor. It's got to be here. General. Please be here. I really want line numbers. Line numbers are like the thing that I find like the most useful as far as like debugging. Cause like you'll get it in the console and then you'll know like, oh, I can look immediately at this specific place. And of course, tabs and windows. Okay, I give up for now. I'll figure it out after the stream. But valuable, valuable to know that I need to set up line numbers. Yeah. Okay. So we have the projectile. It's set up with the velocity. I think that the only other real thing that we could to do is basically let's throw this into our actual scene. So I'm just gonna copy all of these and go to the scene that we imported. I'm gonna use the empty scene, just it's a little easier on my laptop as far as rendering is concerned. And I'm just gonna go ahead and, where's the paste? Paste it. And get rid of that plane because now we already have a plane that's gonna act as our ground. I'm going to move our slingshot over to here. Just rotate it so it's like facing. Oh, I need to add boxes. That's the other thing I need to do. I knew I was forgetting something. I was like, there's still something missing. And it was, yeah, we need to add boxes. That is important. I'll set this to 0 so that everything's aligned. I'm going to rotate my position space so that it's still in front of me because I like that. Let's do that. And as you can see, it's like, oh yeah, they're cameras. I don't need them. It's one, like, I think it looks a lot better when it's bigger. So I'm just going to scale everything up to like 3 times the size. And so now that we did that, I'm going to go ahead, so like this is all working. We can go ahead now and actually just, oh yeah, I don't want that directional light. Let's go ahead and make it. So, wait, what in the world? Oh wait, was that part of the scene? No. Yeah, that definitely wasn't part of the scene. Let's get rid of that. Yeah, most of the lights in this scene are baked, so I'm just going to go to, I actually had this open, but if you want to follow along, it's in window, lighting, and it probably will open up here. Just go to the scene tab and just hit build. It might be an auto for you, but it doesn't take terribly long because we're using the empty scene as opposed to the robot lab scene, which actually has like a lot more models. Oh, you know what I forgot to do? I forgot to, yeah, okay. I forgot to say that the slingshot body is static, but that's fine. We don't have to worry about that for now. This process takes a little bit of time just because it's doing a lot of complicated calculations on what's arguably a lot of data. I mean, oh, it is a lot of data. I shouldn't be joking around as far as that's concerned, but like it's a pretty big scene. So just gonna have to wait for it to calculate everything as far as lighting is concerned. And once that's set up, actually, like while that's going, we can still play around with things. So I'm gonna go ahead and create our boxes. Actually, that's, I think, pretty important. So for that, where did I put it? I put it in models, and like, yeah, the thing that we imported in has a lot of different models, but we are going to use, where is it? It was called Sling something. There it is. Everything's super dark because I didn't add that directional light in, but whatever. I'm just gonna move that over. So now we can go ahead and get rid of the slingshot. Yeah, that's fine. Get rid of the armature. We are going to keep that one. And just so you know, so this scene has light probes, which are all of these black dots that you're seeing everywhere. And basically what that is it's used for real-time lighting. It's basically a bunch of sample positions in our scene, and so that's why it's like literally pretty much all throughout this building. And actually, because I scaled it up, it's not the most optimal. You'd probably actually want to put in a lot more light probes as far as that's concerned. But basically, it's just sample positions throughout our scene that sample the light while we're baking it, which we're doing right now. And then at runtime, we can use those positions to figure out what the lighting would have been at that spot, and then map that accordingly onto the real-time environment. And it's just kind of an efficiency system, basically. And so while that's still baking, so again, just takes time, we're just gonna move our, and oh yeah, and I guess, I mean, the reason I mentioned it is like that yellow triangle is, it's basically picking out which light probes are closest to our object, and then it's just interpolating, or it would basically do the lighting there. So that's what's happening there. And so yeah, so while that's going on, I'm going to go ahead and we're just gonna call this box. Actually, I don't even need the top one. I'm just gonna drag it outside of that, and we're just gonna call it crate. And so while that's running, I'm gonna go ahead and add a mesh collider onto it. No, sorry, not mesh collider, box collider, because this is a box. This is literally a box. And so yeah, so we're gonna go ahead and add that in, and then we're gonna add a rigid body. We're gonna use gravity. It is not kinematic. We want to respond to actual physics. I'm gonna set its mass again also to 100, just to keep all the weights and velocities consistent. These are all numbers you can play around with as far as that's concerned. Not terribly difficult, and I'm just gonna duplicate it a bunch of times. I'm gonna move it below here. 2, 3, 4, and should be reasonable. So that's that-ish. I can get it because we have gravity set up. I don't have to align it perfectly, which is convenient on a whole bunch of levels. So that goes there. You go here. You go here. Maybe move you down a little bit. Of course, like with the gravity though, like you want to make sure that, and just create some more, that it doesn't topple over from too much weight. Rather than the sling rig to maintain rig scale relative to player. These are things you wouldn't think about normally. Yeah, does scaling the room affect our expected physics? Does it affect our expected physics? Not really. I mean, as long as, I mean, if you just kind of think about it as far as like the mass properties are all the same, like forces are all still the same. It's really just the sizing and the scale. And as long as that ball is like approximately the same size, I guess, or like relative to the crates, it should, for the most part, basically capture the scene pretty well. I don't think, yeah, because all the physics calculations are not based on size. They're just kind of based on the collisions, and that's just based on scale. So they're just kind of two independent things. So as far as like Unity is concerned, like it should be fine. I don't think I've run into issues where like the scale has really caused concern unless it like messes with the collider size. But yeah, definitely something to keep in mind for sure as far as like that's concerned. And these are just issues that really happen like when you're thinking about VR and not really about other things. So if I just go ahead and, oh wait, I just have to wait. Yeah, okay. So I think I misaligned one of my boxes, so then it yeah, maybe that one of these is I think too low, or like it's colliding with another accidentally. I don't know where, or like something happened. I don't which box. Oh, I think it's probably this one. Look, there should be space there. Now maybe let's try it. What in the world? Is it just something's happening up on this crate? Which crate is it? Let's space those out so we can actually see. Oh, something's pushing it up here. Oh, is this not aligned to the ground? Oh, there's an extra crate that I missed. That would explain it. That means there's another missing crate up here with whatever I duplicated, right? Yeah, okay. that would explain it. So yeah, clearly the collider physics is working, as it was like, it was not a happy camper at all with the fact that it had overlapping. So now I think it should be fine. Yeah, okay, it's a little high, but which we can bring down so that, all right, is it? Oh yeah, that's really high. Wow, okay. Wait, is it done? Wait, that can't be right. Maybe the directional light was needed. Interesting. Although I thought I brought the directional light in. Maybe I didn't. Okay, I'll just add the directional light in. It's strange. I thought I'll get. Oh yeah, didn't even wait. Yeah, I didn't even build the light map. Oh, is it because I'm moving stuff around? It didn't build the light map. Okay, wait. Yeah, because as you can tell, like there is no light map. So yeah, let's try building it now and see if that helps. Oh, you know what it was? It was because I hit play. I think that canceled. Of course, that canceled it. So, but it should be fine now, and I'll just let that go while I'm adding a bunch of crates to the world. Because we're fine here because all of these objects are not static. So there's a static object here, and basically what light mapping will do, as far as baking lights into this room is concerned, is like anything that's static will be affected by the light mapping. Anything that's not, we don't have to worry about. So it doesn't really mind, or at least I don't think it really minds the fact that we have non-static objects in our scene, and so it can just ignore them um, as far as like actual those objects and the baking is concerned. And so let's just call this a stack. I'm gonna go ahead, drag that in. And if the baking ends up taking too long, I'll just throw that directional light in because it doesn't look as bad. It looks all right with the directional light in there. It's not the greatest. Like the baking really helps a lot as far as fidelity is concerned, but if we can't get it, we can't get it. And so that's a stack. And I'm going to go ahead and just kind of duplicate this and throw this around our scene really. Just make a stack. Going to put oh, whoops. So one thing I should have done is make sure these align up with, sorry, yeah. Well, one thing that you should do is make sure that when you create a game object like this and you want to like move around a bunch of objects just kind of for grouping purposes, make sure it just kind of lines up approximately with your actual game objects. So in this case, the crates. Just so that when I move this game object around, it's up, like tied in closely with the actual crates that we're moving, as opposed to like being off in the middle of nowhere and then not really having a clue about what's going on. So that's one stack. Let's get another stack further off in the back. Let's get another stack. Oops, not what I wanted to do. And yeah, this is just kind of all part of level design, and Valve had to go through the same process for building the slingshot because it's not an actual dynamic, what is the word I'm looking for? Not an actual dynamic setting, or not environment, as far as like the level is always the same for the slingshot game, which I feel like, I mean, it's pretty easy to make dynamic as far as like that's concerned, as like what's explosive, what's a tracer bot, and etc. But that's fine. Yeah, I put in like about 5 stacks. I think that's a pretty good amount. One thing we will quickly do is let's go ahead and create a quick script for forces. So rather explosion forces. So like just kind of defining one of the crates to be this box that explodes. And so to do that, you need to add in this method called add explosion force, and to use it, they just have a nice example script here about how you would actually do that. So for that, what we're gonna do is let's just quickly create a script, call it explosion. Yeah, let's just call it explosion. How did I figure all this out? I think it's just kind of knowing Unity and just kind of knowing what's there and what you can do, and then like the next step after that is like once you kind of get an idea, it's just kind of figuring out what I guess what just Googling, I guess, the proper terms, right? So like when I see an explosion happening in Valve's lab render, it's like you could probably Google something like Unity explosion, and then the first thing that'll pop up is that method. If it's like the parabolic line renderer, you like search for like projectile line renderer or curved line renderer, and you'll get more terms that help you refine the search. What else did I use? As far as like the slingshot, it's from like previous projects I kind of knew about a little bit about rigging, so then I would like ask Abdo like, can you rig like a specific slingshot together, and then he knows how to do the rigging stuff, so like he's able to do that really efficiently. So it's just kind of like being observant of like kind of the smaller details, and then like learning to Google the correct words is, I guess, the best way I would describe that. Let me know if that answers your question. That's just kind of like a lot of different things I said there. So here I'm just gonna do a void on trigger enter. I can't spell for the life of me. Collider other. So yeah, so I mean, yeah, it's just kind of a mix of like knowing from previous projects as well as just being observant about what you see happen in an actual game. So yeah, so this is going to be for the explosion box, and then I want to copy this code. I'll walk through like what that's exactly doing. Needed stack overflow. Need stacked overflow for VR. Yeah, that's what I want to do for FusedVR.com, is basically kind of make that. I think as far as like programming is concerned, like I think Stack Overflow does a good job, but as far as like VR design, yeah, I completely agree. We really do need like a actual hub for designers and VR in general to like actually prosper. But I mean, we're getting there with FusedVR.com, but it'll be slow. Like all good things come in time, right? Private float, let's call this radius. It's going to be 20f. So that covers the radius, covers, let's call this 25f. Sorry, no, I want something a lot bigger, like 1,000f, 10,000f. Get the explosion nice and big. So what's happening here is we get our position. We're going to call that the explosion position, and that's just going to be one box that we define in a stack. That's going to be that one that really does the explosion. Next, what we do is from the explosion box, we create a, do I have anything good? Well, fine, we'll use a controller. So like this controller is just going to be our explosion box, and then we create a giant sphere around it. And that sphere is basically what's going to control the what objects are in that sphere. That's basically what we're looking for. And now for each of those other boxes basically that are in the sphere, what we're going to do is basically check, make sure that they're a box, and we're going to call, for each of those boxes, we're going to call an add explosion force. And then we just apply the force, and then it'll simulate having an explosion coming from our explosion box to the physical, the current box that we want to have feel the force. So it's like not, what we're not doing when we call add force is that we're not just saying that there's a force here and now affect everything. We actually have to walk through all of the objects that we want to have explode and actually activate it on them. So that's what this code does. And yeah, okay, so hopefully, if I cross my fingers, the lighting should be coming out right about, It's still really dark. I don't know why the real-time lights aren't active. I'll just add the directional light in, whatever. I don't know why those didn't get baked properly. Or like, I feel like yeah, there we go. That just lights everything, which is nice. The baking does definitely help, but for whatever reason, the real-time lights aren't active, which I find weird. But it could be, yeah, it could be from, I thought I scaled this right. Yeah, everything is scaled right. These look right. Because this is literally what I did yesterday, but for whatever reason, interesting. Something's off with this project as far as the settings are concerned. I'm not sure what changed, and I'd have to spend a lot of time figuring out what happened. But for now, the directional light makes things a lot nicer. Color intensity of lumens. Yeah, but I didn't have to play around with those. Maybe, I mean, obviously, yeah, that helps. And maybe the scaling really did mess it up. Yeah, I guess, like, maybe all of these ranges really need to be multiplied by 3 in order for it to actually be visible. That could probably be it. But for now, I think you get the general idea of, like, what this is supposed to look like. And, like, it definitely does simulate some of these lights for sure. So not too worried about it, and we can jump back into the previous version if you guys want to see that. Just referencing how it would be in renders. Yeah, no, I think you're right as far as like the lighting scale is off. Yeah, very much so. Yeah, you can definitely tell that these are a lot harsher. I mean, it looks okay, but like yeah, obviously like everything looks like a lot harsher because like none of the indirect light bounces are happening because something went wrong in the baking. And it might just be like, no, those settings look fine. Boost and sense, yeah. Yeah, I'm not sure. Yeah, I mean, part of it is like the real-time lights were also missing, which I found strange. But yeah, I think all of it's just kind of due to the fact that the yeah. So yes, some lights are missing, and I think maybe the scale is a little off. So we could fix those, but I do want to add them. Like we're getting close to 2 hours, so I just kind of want to make sure we add in the explosions. Yeah, there isn't. I mean, obviously, like with having it black, there is no ambient light. I don't believe I had set the ambient light in the other one either. Like, I don't think that was something I used. Yeah, it's set to black. Yeah, so I mean, yeah, it's not doing anything as far as ambient is concerned. So something's off, especially due to the fact there were a few things off. I'm not gonna worry about it too much. Like these are all things, like especially like, because we're using another asset. Like the lighting, like it's not scaled appropriately to that. I think if you're really starting from scratch as far as like building your own world, like you'd know pretty much where you want the lightings and how far you'd want them to go, and then you can bake them in accordingly. Um, but like it's not the end of the world. So I'm just gonna kind of quickly do some things since we are getting kind of close to 2 hours, and I kind of like having these streams be about 2 hours in length. So I'm just gonna to start with, I'm gonna add an explosion force. Oh, you know what? Another thing I want to do is add this. And so in add explosion force, I'll just mention this really quickly, is you have an upwards modifier, and that just really lifts objects off the ground. It's just kind of I feel like it's a little hacky as far as like explosion force is concerned, but it's what's going to lift the whole stack up. So I'm just gonna add the explosion on there. We need to make the box a trigger. And the other thing that we need to do is, and this is actually a little tricky, is one, I'm gonna actually create a layer, call it ball. And the reason for that is I actually don't want the balls colliding with each other. And so to basically ensure that, what you have to do is go to, where is it? Project settings, physics. And here you'll have like a little grid that basically is all the possible combinations of layers interacting with each other as far as collisions are concerned. And so I just want to unselect balls colliding with balls, because otherwise you'll get some really weird issues where if you do have it enabled, like, because you'll have two balls like overlapped for a little bit of time when you're pulling the slingshot back, that just causes issues as far as the collisions are concerned. So we're just going to avoid that issue altogether by not allowing balls to collide with balls. And so then if we go back to our script, if you see here, we had set the sphere collider to be a trigger. And that's just because, like, when we put the hand there, we don't want it to collide. But basically as soon as we release, we can actually go ahead and, so right here, yeah, right here. No, I'll do it below. We can actually turn that off. So r dot is, sorry, not r. It's not the rigid body. It's curveball dot get component collider dot is trigger equals false. So that should do it for that. And let's just try it out. Go. And oh wait, which one was the explosion box? I totally forgot. I can actually, here's what I'm going to do. I'm going to quickly, the colors are backwards, which is fine, but we're going to quickly create a material. I'm going to make it an obnoxious color like blue. Actually, blue is not really obnoxious, but whatever. Which one did I attach the explosion? So instead of the cartoon X, I'm just going to drag that in there so that I know that that's the explosion one, and then I'm just going to aim and shoot down. So I'm just going to move back here. Wait, where'd it go? Wait, what? Why? Why is it red? Oh. Oh, right. That would explain it. Right, so because we actually called the box a trigger, what happened there is it doesn't intersect with anything. So the way you avoid that is you actually create another box collider, and then you make the box collider that is a trigger just a little bit bigger. So we're going to make this 0.028, 0.021, 0.021. So just a little bit bigger. Again, like, that's not a huge deal. It's just so that yeah, there you go. So that it actually stays there. And then I can hit it. Oh wait, did I not apply gravity to it? Wait, that gravity was working before. The ball has a rigid body. Let's actually just move these below. Let's try that again. Wait, why is the gravity not being applied? I'm not sure where. Because okay, so this is that bug that's gonna come and haunt me at the end of the stream, of course. Curveball. So that happened. I'm just curious, like where's curveball? Curveball, I believe I'm only setting. I should only be setting in that instantiate method, right? Curveball line renderer. Yeah, I only set it there, so I'm not sure why. Why is curveball null? Because we're not deleting it. Fell through the world. Yep. So we've solved that. Okay, so why is curveball null all of a sudden? Let's see. We have it enabled. We have. So this line worked because we actually did turn the line renderer off. Here we got the position. We're just saving that. Here we say we move the position and then we set its parent to null. So it shouldn't set curveball to null like that. We should still have that reference. Wonder what happens if I comment that out. Just out of curiosity, if that's causing issues. Ooh. I'm just gonna send it backwards. Yep. No, still no gravity. Okay, I do want gravity to work. Like that's like a requirement for me. For whatever reason, I mean it's clearly setting the velocity. Which is actually interesting, right? It's setting the velocity but not setting the gravity. If I pull that where it is, so it should still be attached here. Yeah. Which that's really strange. Like why? Oh. Wait, no, that can't be right. Oh, okay. There it is. Found it. Okay, so what so dumb. Okay. So what happened was it actually was crouching at this line, and this is because I didn't have my line numbers. I didn't actually notice it. But I had laser arc was not properly assigned because curveball I wasn't using curveball like a component. I was getting it on get component on this object which doesn't have a laser arc. So yeah, if you're following along, make sure you do curveball.get component as opposed to get component laser arc. So now that should fix it. That's just like one of those like sneaky things with live coding, right? And the velocity is probably not set right. Let's see. Okay, so now where is the velocity being set? It should be on the ball. So it's set to 30 by default. But yeah, okay, so it's right. Which is so yeah, okay, so we need to actually update, sorry, not here. We need to update, we need to copy this and put that in here so that we actually get to that thing updating properly, which is this guy. yeah, sorry if I'm not explaining as much, but I just kind of wanted to get everything looking right, I guess, right now, before the stream ends, which, yeah, just to make things like happen really fast, right, for you guys. And this is just live debugging, just YOLO style. This is dot magnitude. There we go. Let's try that out. Yep, okay, so now that's actually probably along the lines of what it should look like. We're just gonna make that a lot faster at around 100 so that it goes a lot further. Go approximately, still not fully right, at least not exactly like where I want it to go. That's the velocity I use, right? So slingshot start, curveball, the transform that position. My velocity, that looks all right. I believe I set all those variables right, unless the gravity, I think everything should be set up right, unless I'm like missing something. Like that projection doesn't look exactly the way I want it to. It's like magnitude dot strength. Well, there's this. Oh wait, no, that's not. That's fine. You know what? For now, I'm just going to like max out this velocity, and there might be some setting that I missed, which, there we go, come on. That should be about, it's still not going nearly as far as it should. Start off velocity. Okay, now this is at the point where I'm like, it's getting late, and I'm going to go ahead and quickly make sure I didn't miss something in my own, in the test script that I built a while ago, or like 2 days ago, is more like it. And yeah, I had a lot more code in here, but RDOP velocity, yeah. Like all of this looks right. That's just not going nearly as far, which I don't know if I put extra drag in. This is interesting. So I guess just all of the things that a normal VR dev, or like really any game dev, will go through is just like random bugs just kind of popping in out of nowhere. Line numbers in Visual Studio should be language preferences. Let's check it out. Where's preferences? Tools? File? No. No. Search. Probably options. Language. Nope. That's not it. Options, text editor. All languages. Text editor. Behavior? No. Oh wait. Oh, this is monodev. I was like, wait, why why is this different? Windows, tools, nope, tools, options, text editor, all languages. Yes. Thank you, Zypher. Am I pronouncing that right? Thank you for adding that in, because line numbers are the most valuable thing in the world for future reference. Yeah, I don't want to. I could just apply this, and then I know it'll work, because this is what I used at the beginning. Although there were bugs with that also. So, yeah, it's like 12:05 now. Yeah, and I don't want this to go too long, so I will take a look at this, and I'll post a comment below as far as like why specifically this wasn't working, as far as like why the laser arc was like projecting a lot further than it was supposed to. But yeah, I mean, that's just kind of the gist. I mean, we still have it firing, and it's definitely, I think something is off, I think, with the velocity that's set. The hair? Oh yeah, it's like probably right around here. That's VR hair. VR hair for you, ladies and gentlemen. um, so yeah, I've noticed that happened. I think I probably need a haircut. That'll solve things. So next week, stay tuned while I get a haircut. But yeah, I'll figure this out offline, and then I'll post something in the comments or somewhere, maybe on our website also, just that, yeah, probably on that blog post so that people know. But hopefully this was helpful a little bit, and as far as just kind of getting started, because I think that's kind of what I want to do with these streams, is like help people get started on their own projects, and then once you do, it's just kind of going ham. And final plug for filling out that poll, because again, super valuable for me. But yeah, that's pretty much it for this week. And yeah, just kind of based on the results of that poll, I'll figure out what we want for next week. And also, if you have suggestions, I'll also put a plug in here for going to fusevr.com. If you sign up, you can also just drop some suggestions in here. That'll also help me out for figuring out what people want to see. But other than that, if you enjoyed this, just leave a like on the video, or subscribing means the world to me. Just knows that people appreciate what I'm doing. And other than that, I will see you guys next week. This has been FuseMan. I'm signing out. Boop.